Hello. Hello, everyone. Good afternoon here. So today I'm going to give a talk about ChainStorage, which is an open source blockchain data availability and agility layer in Coinbase. So here's my own introductions. And I'm the head of data performance services in Coinbase. So my team actually runs all the Coinbase data, business data, that including business data and blockchain data and blockchain data applications and blockchain research, etc. So I am, just a second. I am a father of three wonderful kids. And my crypto career, including 2013, I was buying my first Bitcoin from Coinbase while holding my daughter in my arm. And yeah, I still regret I didn't buy that many. And 2016, I wrote my first line of Solidity code in Ethereum. You can actually contact me using Telegram, as well as that's a new one, which is a Coinbase wallet. You can actually message them the XMPT protocol. In case you don't know what Coinbase is the largest compliant exchange in US, probably in the world, compliant. That's number one. And Coinbase mission is to increase economic freedom in the world. Coinbase is an exchange, but it also has a very rich line of crypto products. It has Coinbase Exchange, which is a Coinbase app. Coinbase Main app is an centralized exchange allow you to buy and sell cryptos. Coinbase Wallet, which is self-custodial wallet that enable you to store your cryptos in the self-custodial way. We have Coinbase USDC, okay, that's called USDC, which is the stablecoin, one of the most used stablecoin in the world. Coinbase Earn is a program that enable crypto users to learn crypto and also earn crypto as well. Coinbase Pro, now rebranded as an advanced trader, which is enable professional user to actually trade crypto. And we have a bunch of the business line of the product as well. Okay, here's the agenda. We have like 12 minutes-ish. So let's get faster. So I will actually go through what data is in Coinbase is, and also we'll talk about very specific blockchain data in Coinbase, and we'll present our solution, ChainStorage, and explain the why and hows, and also introduce the ecosystems. Coinbase data. This is what a crypto company data needs to look like. Coinbase has three kinds of data. The first part is a blockchain data. Second is a product data, external data. All these data have their own characteristics. Blockchain data is publicly available, and when we talk about blockchain data, it really means the transaction blocks and all the derived data, as well as chain-specific data. And we use that to actually support various of different blockchain applications. Product data is a proprietary. Some of the data is user generated and some of them is user behavior. We use that to help with user to make them have better application experience. External data is interesting. It's a vendor supplied because no one has all the data. We have to source some of the data outside, which is from some of the vendors. And for example, we actually getting the price data, some of the price data from outside. We also actually getting some of the exchange trading volume from outside for analytical purpose. Use case of blockchain data. So because this talk is about blockchain data, right? So let's focus on the first vertical of that. Use case of the blockchain data. We have three kinds of use cases. Number one, it's a near real-time blockchain data applications. That including when you're actually building a wallet, and then you need a wallet indexer. When you want to display NFT, then you need the NFT indexer, right? So this kind of application, including block, transaction, tokens, balancer, you name it. The key ask for this kind of data is the backfill performance, because you won't get it right at the first shot. You need to do multiple iterations, and as the application evolves, you need more or less data for your index. And also the data freshness matter, right? You want to see your token balance in seconds, not hours, not minutes. And that matters. The second category, it is complex analytical workload. We produce a lot of the on-chain metrics in Coinbase. For example, we need to analyze where the money flows, and for example, the bridge analysis. And we also have machine learnings, on-chain machine learnings, on-chain data machine learnings. And for example, to produce a NFT price predictions. This kind of application require us to have ETL tables, streaming data sets, some of them in real time, some of them in less real time format. And we require this set of application, we require the data need to be flexible and ecosystem integrations. And because we do not want to reinvent everything, right? We want to connect our system into the big data ecosystem, things like Spark and Ray, in order for us to process it. Last category is very enterprise specific. It's called high trusted data. As a crypto company, even though everything on blockchain, we still need to actually do things to connect to the real world. For example, we need to making sure the particular transaction is confirmed. We then actually send out the token, because otherwise we lost money. And we also need to do account conciliation to making sure the accounting is, the ledger is actually balanced in real world, so that we can do quarterly report, right? Coinbase is a public company, just a reminder. And we also need to do fund flow to making sure the money flowing in, flowing out are coming from a good guy and never flow to a bad guy. And for these cases, data lineage matters and verifiability matters. So let's get into the requirement. Given you see so many use cases, it's very, very mind-blowing. Coinbase is a crypto company. I stress that again. Blockchain data is the core need of its business. As a company, the first part of the requirement is data self-sovereignty. Why that's important, right? It's a public company. You need to making sure your company, you need to actually make sure the data that you have is trustworthy, high quality. That's a must requirement. Also, privacy and compliance. Think about that. Would you like your bank to send your account numbers to a vendor in order to fetch the balance? Probably that's not a good idea, right? So we need to actually build all this capability in-house to protect your privacies. Cost efficiency matters. We cannot afford to put $50 million a year in order to use all the blockchain data in various form. And that explains itself. We also need to get repeatable calculations. So when something is wrong, and then we can replay the calculations and we know why it is wrong. And more importantly, we want to support heterogeneous blockchains at our own pace. We don't need to wait for a vendor to have that. Second requirement is data availability. Data availability is a very big topic. The definition of the data availability here in some sense is similar to Ethereum, but in a more centralized form. It has 3 dimensions. Number 1, you have the data there. And then second, our user can access to the data. And third is a trust. The trust is really means in the sense that the systems have sufficient assurance that the full transaction data was made available for verification without the need of our user to download the full transaction. For example, things like macro trees is one of the examples that we support there. And the last concept, the last requirement is called data agility. This is relatively new. Data agility really means 3 dimensions. Flexibility, user can iterate and perform their own data experiment to shape the data into the target format that they want so that they can support their own applications. Efficiency, with the cost and the human time in that particular dimensions. Ergonomics is easy to use and easy to integrate with the existing systems. Solutions, that's ChainStorage. The TLDR, if you only remember one thing about ChainStorage, it is a file system of blocks. And I give you a 10,000 feet view. 10,000 feet is around 30.48 kilometers. So just in case you don't know. So give you the overview for that. It has a coming, okay, this is a list of components. You have the ingestion system that taking the block from the nodes in the robust form, and they store it in the lossless format. Block storage, you store the block into a block. So you just put that in the S3 in some practical sense. Meta storage, maintaining the relationship between the blocks so that you form a chain with all these files. And we also have a output format transcoder that will convert the block or range of the block into a target format, JSON, packet, some example, including Rosetta as well. And each of these components expose manageability endpoints in gRPC service, so you can interact with each of these systems and understand how it runs. So you can manage that over there. ChainStorage can take the blocks in the robust and the trustless form. What does it mean? It is vendor failure resistant. So you can have a multiple node vendors. You name it. I can't actually name the actual vendor here, right? But you name it. You can pick the vendor that you want. You can pick multiple that you want. They will actually get a block from there. If some of the vendor went down, it fails over. And also, you do not need to actually trust the vendor data, because when inside the ingestion, it actually built in the verification form, making sure the data you ingest into the system is correct, mathematically proven to be correct. And when users consume the data, users can use the SDK to verify the data that they get is correct as well. So this is the overview. Let's move down a little bit, 10,000 feet-ish. To take a look at one aspect of ChainStorage. Because we cannot actually go through the whole design, because the whole design will take hours in order to go through that, then I just cherry pick 3 very special characteristics of ChainStorage. Number 1, lossless. All the blocks content are stored in the raw form inside the file. So this is important. A, you can recompute the macro tree to verify the data is correct. B is all sorts of the data application can build on top without the need, with minimum need of the node again. Second, reorg aware. And that's very important. That really means our user doesn't need to worry about blockchain reorg. For the recent fast blockchain, you probably will notice that the train reorg event is happening much often than you thought. And some of them is like more like 5%. That gives a huge problem for the downstream user to consume the blockchain data, because when you have the block, all of a sudden the block disappears, right? So we provide the interface for people to consume the stream or consume the table always in the canonical train. And the third is we adopt the blockchain problem. This transforms the blockchain problem into a big data problem. So if you're a good data engineer, after you interacting with ChainStorage, you probably forget you are interacting with a blockchain data. You no longer interact with blockchain directly. Result. Here's the result. This is the performance. So the throughput, we try to benchmark that in a fair way. It is around 100x performance comparing to a vendor, comparing to a popular node vendor, and much better latencies, and 20x of the cost saving, the same amount of workload. So without using ChainStorage, we probably paying 700K. They may actually give us some discount, but you know that's a different magnitude problem. But with ChainStorage, only 30K, and it also resists to a particular vendor failure as well. Okay, now let's talk about the ecosystem. I have 2 minutes. So ChainStorage give you the access to the block. But that's not enough. We have a last mile. How about big data? We have a system called transformers. On the high level, transformer, it is a data adapter that turns the raw data inside ChainStorage into unbounded, well-defined schemas. It's a stream. So some big data concept, when data in motion is a stream. When data static is a table. So unbounded stream, which means unbounded table. So for users, that what they get is, you can see the example here, right? They can just read the data source and then load a particular data set, and then they just write that. And for users, they will actually get is a table, just keep populating itself. You can build your application directly on the table. And the job actually here is actually written in Scala. Of course, you can actually write that in Python as well. So these enable our data engineer to use the familiar tool to perform the work that they have. Okay, the second key component of the ecosystem is called ChainNode. Think about that. A lot of the DApp application depends on the RPC interfaces, right? So ChainNode, it is the component that converts the ChainStorage data into the RPC interface and expose that to user. User can directly build on top of that. And what's the result? The result for that is very similar or better performance comparing to the node provider. Besides, we have 10x to 100x throughput and a fraction of the cost. So open source, that's the last slide. And we believe that we have a very, very solid foundation for enterprise-grade blockchain data stack. When we talk about enterprise, I really means big company, as well as if you are running a train, you should actually adopt that as well. The reason that we open source it to helping the industry not to worry about blockchain data access in the coming bull run. This is the last thing that you need to worry about. Practically we enable the alternative to build blockchain data availability and the agility layer for enterprise with self-sovereignty. And more importantly, we need your help. It is still very early time for the open source, and welcome to feedback. Feel free to reach out to me, and yeah, here's my contact. Thanks very much.
Unfortunately, we don't have time for any questions. There is the Vitalik talk in 5 minutes in Building A main stage. Thank you.